notes. If you see this little dude here who's thinking, that means I want you to pause the video at a certain point. You're going to probably work out a problem on your own, and this is a signal to you that you're going to need a graphing calculator, okay? Pretty basic. So let's get into what a function machine is. Okay, this is really easy stuff. That's what's nice. One of the easier lessons of the whole year, because you should already know this, so we're just going to kind of go through some things. I'm also going to teach you some calculator skills in this lesson that you may not know. So what goes into this function is going to change when it comes out. Maybe change, maybe it doesn't. But what comes out depends on what gets put in. What comes out depends on what gets put in. So for example, here you got a picture of Mr. Brust. And if you take Brust and you put him into this function machine, what's going to happen? And what comes out?
Steve Urkel at your service.
Brust goes in, Urkel comes out. Let's take Mr. Kelly. Kelly goes into the function machine. And then what comes out? Another Urkel. Now this is okay. A function machine can do that. You can have both Kelly and Brust go into it and come out as the same thing. What has to happen though is if I put Kelly in, Kelly always has to come out as Urkel. If he ever comes out as anything else, it's broken. So for example, here let's take Sullivan. If Sullivan goes in, what comes out?
Excellent! I win! I like it when I win.
Mr. Crocker, the guy from Timmy Turner, if you don't know who that guy is. And if we took Sullivan again, so let's take Sullivan and just plug him in again, then what is it got to be? It should be Mr. Crocker, but look, it's not. He came out as somebody else.
Any last words, puny Earth boy?
I don't even remember this guy's name. The tough guy, you know, from Timmy Turner. This is not a function. Sullivan coming out as two separate things, both as Mr. Crocker and the tough dude, then this can't be a function. It's broken because you got to be the same thing every time. So for example, here you have a little table. Let's just fill these out real quick. If I plug in a -2 as an input and I get a 25, I'm making numbers up here. 25, then a 0, then a -4. Now watch this last one here. This -2, I plug it in. What does that have to be? It's got to be a 25. Uh-oh. This is not a function. So we would write underneath this, I want you to write down that it is not a function because of that value right there. So if I was specifically explaining it, I would show that the input of -2 is coming out as two separate outputs. So it's broken, not a function.
Okay guys, so what he's basically trying to say is that every input can only have one unique output. In order for the function machine to not be broken, each input has to have exactly one output. In this case, -2 is the input, but it has two outputs, not a function.
Next one, -56 comes out a 4. We plug in a 1/2. Well, it also comes out a 4. And the 0 comes out a 4, and the 1 comes out a 4. So in this case, they're all the same thing. That's okay. What would matter is if I have a 1 here and a 1 somewhere else, if it came out something else, then it would not be a function. This one is a function. Next, we have these values here. So the only thing we really need to worry about is this 13 on the top and the bottom. So let's see. We get a -54, a 12, a 0.2. So if I plug in this 13, this one needs to be a -54. And if it's not, then it's not a function. And it is a -54. So this is a function as well. Okay.
So in your notes, I would write that as your definition. A function is a relationship where each input has exactly one output. I'd also include an example of a table that is a function and a table that is not a function so that you can refer back to that later.
So hopefully that helps you know with just tables what you're doing with input and output. Now let's get some other names for input and output. You can also call it independent, because input and independent, I'm trying to help you remember, this is the independent variable. The input is the independent. The output is the dependent. Just remember the IN. Another name for it is domain and range. That should be kind of familiar to you. Domain is the input, range is the output. And X and Y, we often use these X's and Y's. It does not have to be X's and Y's. We're going to have lots of different variables. We'll practice some of that today. But often we do X's and Y's when we're graphing things.
Yeah, so the independent variable goes on the X-axis. The dependent variable goes on the Y-axis, so X and Y.
Remember that it's alphabetical. D comes before R, and X comes before Y. Alphabetical, just to remember their order. That doesn't work over here with the independent and the dependent, because you got to remember the in and the in goes together. Okay, so we got some names down, so you can refer to those. Again, hopefully this is just some review, but maybe it's clarifying it for you if you've forgotten some of the stuff. So where do we put the input variable? This is called function notation. F